For centuries, humanity has gazed at the night sky, captivated by its endless mysteries and the twinkling lights that stretch across the darkness. We've always wondered if we are alone, or if somewhere out there, other forms of life might be looking back at us. Driven by curiosity, we've sent robotic explorers across the solar system, searching for signs of life and water, the essential ingredient for life as we know it. On Earth, wherever we find water, we find life, whether in boiling hot springs or in the deepest, darkest ocean trenches where sunlight never reaches. So our search for extraterrestrial life is, in many ways, a search for water, wherever it might be hiding in the universe. Once we thought Earth was unique, a blue oasis in a dry universe, the only world with vast oceans and rivers. But new discoveries have shattered that view. Water is everywhere, across the solar system and beyond. We found it as ice on the moon, and as hidden oceans beneath the thick, icy crusts of distant moons like Europa and Enceladus. We've even detected vapor clouds drifting in the vastness of deep space, far from any planet. Mars, our red neighbor, has long teased us with evidence of a wetter past, ancient riverbeds and lake bottoms carved by flowing water. The real breakthrough, though, came not from a rover's camera or a single photograph, but from listening to the heartbeat of Mars itself, using sensitive instruments to detect water deep below the surface. This quest for water is reshaping our understanding of the cosmos, revealing that the ingredients for life may be far more common than we ever imagined. And with every discovery, the possibility of life beyond Earth grows ever more real, fueling our imagination and our determination to keep searching. The most profound discovery of water on Mars came from the InSight lander, a mission that forever changed our understanding of the red planet's hidden depths. InSight was a robotic geologist meticulously designed to probe beneath the Martian surface and study the planet's mysterious interior. Its sensitive instruments listened for Marsquakes, seismic tremors that ripple through the crust and mantle, carrying secrets from deep below. These subtle vibrations revealed something astonishing and unexpected. The seismic waves slowed down and reflected in patterns that pointed to the presence of liquid, not just solid rock. By carefully mapping these signals, scientists uncovered evidence of a vast layer of fractured rock, hidden far beneath the surface. This layer was saturated with liquid water, locked away in the darkness deep below. This isn't just a small isolated pocket of water. It could be a global underground ocean, stretching 11 to 20 kilometers beneath the Martian crust, encircling the planet. At such incredible depths, the pressure and insulation keep the water in a liquid state, safely shielded from Mars's harsh, freezing and radiation-bombarded surface. For now, this water remains out of reach, buried too deep for our current technology to access, but its discovery marks a monumental leap in our quest to understand Mars as a dynamic, evolving and possibly habitable world. Before InSight, Mars's upper crust appeared dry and lifeless, a puzzle considering the abundant evidence of ancient rivers, lakes and flowing water that once shaped its surface. The discovery of this deep aquifer finally solves the mystery. Much of Mars's water didn't simply escape into space. Instead, it seeped underground, where it remains hidden to this day. This groundbreaking finding transforms our view of Mars's water cycle, rewriting the story of water on the red planet and opening up new possibilities for life, past or present, in the hidden depths of Mars. NASA's rovers have explored Mars's surface, uncovering minerals and landscapes shaped by ancient water. The discovery of a deep underground reservoir links Mars's wet past to its dry present. As Mars's climate changed, surface water seeped downward, protected from the thinning atmosphere. This mirrors Earth's own underground aquifers, where water is stored far from the surface. The ancient river valleys and deltas aren't just relics, they're the entry points to Mars's hidden plumbing system. Mars isn't just a planet that had water, it still has water, just buried deep below. This continuity makes Mars a compelling target in the search for life, hinting that habitable environments might still exist today. The story of water on Mars is far from over. Mars isn't alone. Water is a recurring theme across our solar system. From the smallest moons to the largest planets, the presence of water in one form or another connects these distant worlds. Even the moon, once thought bone dry, hides ice in its shadowed polar craters, potential resources for future explorers. These frozen reserves, locked away in perpetual darkness, could one day support lunar bases or fuel deep space missions, making the moon more than just a barren rock. Saturn's moon Enceladus stunned scientists with plumes of water vapor erupting from its south pole, evidence of a subsurface ocean in contact with rock, an environment that could support life. The Cassini spacecraft revealed these geysers, hinting at hydrothermal activity similar to Earth's ocean vents, where life thrives without sunlight. Jupiter's Europa is even more promising, with a saltwater ocean beneath miles of ice, possibly containing more water than all of Earth's oceans combined. The cracked, shifting surface suggests a dynamic world, where tidal forces from Jupiter keep the ocean liquid and active. Plumes on Europa hint at exchanges between the ocean and the surface, offering tantalizing targets for future missions. By sampling these plumes, spacecraft could search for organic molecules or even signs of life without drilling through the thick ice. Each world reveals a different form of water, frozen on the moon, buried on Mars, and as vast oceans beneath ice on Enceladus and Europa. This diversity shows how water adapts to the unique conditions of each celestial body. These discoveries, made with everything from orbiters to direct plume sampling, show our solar system is far wetter than we ever imagined. Each mission uncovers new clues, expanding our understanding of where water, and possibly life, might be found. Water isn't rare. It's a defining feature of many worlds. Its presence shapes landscapes, influences climates, and raises the possibility that life could emerge in unexpected places. The search for water is transforming our understanding of where life might exist. As we continue to explore, each discovery brings us closer to answering one of humanity's oldest questions. Are we alone in the universe? Why do we focus so much on water? Because it's essential for life as we know it. Water dissolves and transports nutrients, enables metabolism, and provides a stable environment for life's chemistry. On Earth, life thrives wherever there's water, even in the darkest, hottest, or most isolated places. Extremophiles flourish around deep-sea vents and miles underground, surviving on chemical energy, not sunlight. These earthly examples suggest that life could exist in Mars's deep aquifers or Europa's hidden seas. The discovery of liquid water on other worlds is more than a curiosity. It's a signpost for habitability. Water doesn't guarantee life, but its absence makes life as we know it nearly impossible. Every time we find water, we find a place worth exploring for life. Water's story isn't limited to our solar system. It stretches across the universe. In 2011, astronomers discovered a colossal cloud of water vapor around a quasar 12 billion light-years away. This cloud contains 140 trillion times the water in Earth's oceans, existing when the universe was just 1.6 billion years old. Its presence shows that water's ingredients, hydrogen and oxygen, were forged early and spread quickly across the cosmos. Using spectroscopy, scientists detected water's signature in the light from the quasar, revealing the chemistry of the early universe. This discovery proves water has been abundant since the dawn of time, not a rare cosmic fluke. Planets forming around distant stars could have had access to water from the very beginning. The story of water is universal, woven into the fabric of the cosmos. We're living in a golden age of discovery. Hidden oceans on Mars, icy moons, and water clouds at the edge of the universe are rewriting our understanding of where life might exist. Earth is no longer a lonely oasis. Water and the potential for life is everywhere. The next steps are clear missions to drill through Europa's ice, sample Enceladus's plumes, and one day probe Mars's deep aquifers. These challenges are immense, but the question, are we alone, drives us forward. Discovering water throughout the cosmos deepens our appreciation for Earth and the fragile conditions that allow life here. We are part of a vast cosmic story, one of water, rock, and the potential for life. The journey is just beginning. Mars's hidden water is a starting line, not an endpoint. Where there is water, there is hope, and the promise of even greater discoveries ahead.